Hello, everyone. I'm audible. Okay, so fine, guys. Good evening. So I think I'm audible. Yeah. So let's start with the class and let's see a topic that we are going to discuss today. So let me share my screen. Yeah. So I think in our last class, we were talking about linear regression, and I have given you a task, and many of you have already completed a task. And I believe most of you have already received some sort of a reply from my side that whether it's good, it's not good, or whatever it is. But yeah, so I have responded back according to the work that you have done. So fine, let's start talking about today's agenda. So again, it is a continuation of the last lecture where we were talking about a linear regression, but there are something like some different topics, some different modules that we have to discuss. So let's try to talk about it. Okay, so last class I was talking about this one. So let me import same data set again. Let me re-execute exact same thing. And this notebook is already available inside your dashboard. So those who are not able to go through a recording, so please try to go through a recording. Things are connected. So if you are not going through a recording, so in that case you will miss out. And yes, from there I think you can try to understand. And those who have not submitted their homework, so please try to submit it. Homeworks are important. Okay, so now let's start. So last time I was talking about a linear regression, and we have discussed that, okay, so linear regression or any kind of a machine learning models is nothing, but it's more like we try to understand a pattern into our data, and then we try to fit our data set or a pattern of the data set on top of some sort of a equation. Apart from this, so we have already discussed that how this like all this machine learning algorithm works, what kind of interpretation or hypothesis try to understand, and then accordingly so it will try to shape an entire equation. So now today I will be talking about a multi-linear regression. So last time I'm assuming that we have taken only one feature, right? Only one feature versus one label. In today's class I will be talking about a multi-linear regression, so where we are going to consider a multiple features, and then we will try to build a model, and we are going to talk about some of the additional topic called as adjusted R square and regularization, multicollinearity, and all sort of things. So there are so many things which we have to discuss. So if I'll ask you a question that linear regression is a low bias, high variance model or high bias, low variance model, so anyone who can try to answer? My question is, again, I'm going to repeat my question. Yeah. So whether linear regression is going to give you a low bias, high variance or high bias, low variance model, because I'm assuming that we have already discussed this bias things in our previous classes, probably in the stats classes. Yeah. So, okay, people are saying high bias, low bias, high variance. Okay, overfitting. So we have a mixture of answer. Okay, so some of you are saying that it's a low bias, high variance model. Some of you are saying that it's a high bias, low variance model. So by the way, let's clarify this particular topic, right? Let's try to clarify this particular part, that why we are saying that why we are trying to talk about this bias and variance, right? So I'm assuming that we all are aware about a bias and variance trade-off. Bias is nothing but error, or variance is nothing but dispersion of the data set, right? So whenever we are trying to build a model, right? So whenever we are trying to build a model, so for sure it is going to adjust itself, or it will try to understand a relationship in between a data. It will try to adjust itself, and that is going to happen based out of the error. Or you can say error is nothing but a difference between y and y hat. In other term, we can say cost function or loss function as well. A difference between y and y hat. So if difference will be more, means if error will be more, it will try to adjust more in a general way, right? We can try to discuss. Okay. Now, so by default, a linear regression is going to be a high bias, low variance kind of a model. Why I'm saying that linear regression is going to create a high bias, low variance kind of a model? Let's try to understand it, right? So I'm saying that it is going to give you a high biased model, right? Now, what is the meaning of this bias? A bias is nothing but a kind of an error that I will be able to receive at the time of training, right? So it is going to be a high biases because we all know that even if my data set is scattered, let's suppose this is my data set which is scattered, right, across a plane, and if I'm going to draw a particular line, right, if I'm going to draw a particular line over here, so at any point of a time, if I have to do a prediction, so it is going to give me a prediction over to a line, right? So if I'm going to give some sort of an input, right, so it is going to give me an output out of this particular line which it has drawn, right? So there is a very high chance. So I'm talking about these things after a training, because after a training, so I will be able to see, or I will be able to receive, right, this particular line. So here there is a very high chances, there is a very high chances that it is not trying to give you a exact result, because all the results it will be able to give you based out of the single line, because this is the only line that it is going to draw, right? So there is a very high chances that it is not going to give you a exact and accurate result on top of this particular line which I have drawn out of the training. So for sure bias or error will increase. But here, so if I'll talk about a variances, so even if I'm going to give more and more amount of a data, more and more amount of data means, so here, if I'm going to add, let's suppose a more number of dot or more number of data, but you will be able to see a very small changes in a position of this particular line, right? It is not going to adjust itself much. And this is where a variance comes into a picture. So variances of this particular line. So maybe it is going to shift itself from here to here. There is a possibility, right? Or maybe shift itself from here to here. There is a possibilities. So variances of this entire line or adjustment of this entire line is going to be a very, very low. So that is the reason it's called as a low variance model. So linear regression always creates a high bias and a low variance model. There is a very high chances that at the time of a testing, right, whenever you are giving a new data set, it is not going to give you a very accurate result that you are expecting. Maybe like 80%, 90%, that is completely fine. But any result it is going to give you based out of a line itself, a fixed line that it is going to draw at the end of the training based out of your m and value of c, which is nothing but slope and intercept. So it's called as high bias and a low variance model over here. So I think this idea is clear why linear regression is a high bias, low variance model. Yeah, everyone. Yeah. So this is the kind of a questions people generally ask in an interview, that whether this linear regression model is a high bias, low variance. It's kind of confusing always, right? It's always create a high bias, means more error at the time of training, and a low variances means in terms of adjustment of the line, right? So yeah, bias means error for sure. Okay, मुझसे पूछा था sir exact question, what is bias? Yeah, so this is like a very common questions that people will ask you. Bias and variance trade-off and bias and variance with respect to a different algorithms as we will try to progress, right? Today I gave a written exam for KPIT. The same question was asked in the exam. Try to attend all the lectures, so no one will ask you any questions beyond this part. I can assure you on this. Fine. Now moving ahead. So moving ahead, right? So basically, linear regression is nothing but it always creates a high bias and low variance models. Now here, uh, we can try to build maybe a multi-linear regression model. Now, what is the meaning of multi-linear regression model? Very simple. a multiple feature and one single label. At any point of a time, label will be equal to a 1, means your y column will be 1 and your x values can be x1, x2, x3 and so on, right? So if you remember a data set that we have taken for this particular example, which was a very simple data, by the way, right? So this is the data set that we have taken. So if I'll try to print df, so this is our data set that we have taken, right? And we had 3x feature column and 1 label column. Again, that is completely fine. Last time what we have done, so we have taken only one single column and then we have built a model. This time what we can do, so maybe we can try to consider a multiple columns and then we can try to build a model, possibly, right? Okay, so let's try to do that. Let's try to take or consider multiple like x values and then try to build a model. Again, this is going to be very, very easy. Yeah, so you're not supposed to worry about it. So let's suppose if I'm going to like I have to create first of all a separate feature as well as a label column. So maybe what I can do is, so I can try to create maybe some data, right? Data underscore x we can try to create, which is nothing but a feature column I'm talking about. And it's nothing but a df of, I have to select maybe a TV, radio and a newspaper. So fine, I can try to select TV, radio and newspaper over here. Okay. So TV is done and your radio is done and your newspaper is done. So this is the data that we are going to create, right? So TV, radio and newspaper. Now what is my y column? So y column will be nothing but, maybe I can try to do df dot sales. This is the column name, I believe. Yeah, so this is my y column. Yes, so we have 3x value and we have only one label always, right? So we can have multiple x values, x1, x2, x3. So yes, we do have x1, x2, x3 and we have a y. Now in this case I have to build a model. Again, we can do that. So what we can do is, so maybe we can try to create an object of a linear regression, right? So object of a linear regression we can try to create over here, and then lm dot what? So lm dot fit we can try to call over here. So when we are trying to call this lm dot fit, what will happen? So we have to provide data underscore x and a y value, and this is a regressions that it is going to build. This is the model that it is going to build. I can try to call maybe linear dot intercept, and I can try to print what? So I can try to print maybe a coefficient, right? Now what is the meaning of this and what kind of equations we have built? Let's try to understand this particular part. So after building this particular, because I think we all are clear on this part, right? No one is having any kind of a confusion. We have done the same thing even in last class. Yeah, so no need to talk about what is this import or what we have written. Yes, we all are clear about each and everything, intercept, coefficient, everything we have discussed so many times, right? Okay. Now here, so how my equation will look like? So if I'll talk about an equation, so your equation will look like in this particular way. So 0.04 so TV, radio, newspaper, right? So here, this is how your equation will look like. 0.04 of TV plus 0.188, this one, right? Radio plus or minus over here, as it is having a minus sign, 0.00103 of maybe a newspaper. Plus what? So 2.94 I can write. Yeah. So can I say that this is the equation that we have built? Yes. So this is the equation, or this equation is equivalent to m1 x1 plus m2 x2 plus m3 x3 plus c. So this is the exact same equation that we have built, right? So where we were trying to find out a 3 value of like a m, so m1, m2, m3, which is nothing but a respective coefficient for our respective columns, x1, x2 and x3, and this is nothing but our intercept. That is like a by default we will try to find out. So this is equations that we have built over here. So where we have like a three, like a coefficient and one intercept, right? So, and this is the equation. So if someone is going to tell me that, okay, fine, so what is my investment on TV and radio and newspaper? So can I say that I will be able to give them a sales, a Y value? Yes, agree everyone? Yeah. So we all will be able to do that, right? We all will be able to do that easily. So if someone will give me like what is the advertisement expense you are going to make on TV or radio or newspaper, so I will be able to tell you that yes, this is the sales you are going to make, or this is the sales that you will be able to do at any point of a time. This is something that I can adjust or understand easily. Now if I have to find out a confidence of this particular model, right? What is the meaning of confidence? So meaning of confidence, again, in layman way, if you have to understand, so out of 100 data, let's suppose if I'm talking about this 100 data, so out of 100 data, for how many number of a data point it will be able to give me a correct result, right? This is somewhere, this is, you can try to relate with the confidence. So let's suppose if out of 100 data for 90 data set, if it is giving me approximate same result, and for 10 data set is not able to give me approximate same result, maybe in that case I can say confidence is 90%, right? So in this way, so now if I'll tell you, can you please tell me what is the confidence level or score or R square? This is what we have discussed. R square is nothing but 1 minus residual summation of square divided by total summation of square. This is what we have discussed in our previous classes mathematically, right? And even we have seen all those things with respect to a code. So if I have to find out that what is a confidence of this model, what I should do and how I will be able to find out. Yeah. So I think we have done that, right? In last class. Okay, so someone is saying like a p-value, someone is saying R2 underscore score. I think if you look into your slide, right? So last time we have done this part. We were trying to call model dot score. We were trying to give like a value of X and Y. And yes, we were able to get a result. This is something that we have already done. I don't know why you are not able to recall these things. So here what I can do is lm dot maybe a score I can try to call. Here I can try to pass like X data and we can try to pass Y data. And 89.72 is a score of this particular model when we are considering all these three columns, right? So when we are considering all of these three columns, TV, radio, and a newspaper, at that point of a time, my confidence score is equal to 89.72%. And what is the confidence score that you were able to get when you have used only one column? 61%, right? So 61%. So now if you will try to understand a previous result that we have received and a next result that we have received, now can I make a conclusion that we are supposed to consider a multiple column instead of considering only one column over here? Yeah. So can I make this kind of a statement that yes, we are supposed to like consider all this three column, right? We have already done that. Let's suppose if I'm trying to select maybe just two columns, right? So I'll try to do one thing. So I'll try to select only two columns over here, right? Only two columns, and Y will be same. My data frame dot sales. This will be my column, and then LM1 I'm going to build linear regression, and here so LM1 dot fit, and I can try to pass data. Let me, yeah, so X comma Y over here, and LM1 dot score I can try to calculate, where I can try to pass data as well as Y. Now here, so when I'm trying to take TV and radio, I have just removed newspaper. Last time what I have done, So last time I have taken TV, radio, and newspaper. Agree, everyone? And very first times I had just taken TV. Let's suppose here I'm trying to consider, or I'm trying to take a TV as well as a radio, right? Now, what is the score that we are receiving? And what is the difference between all and this two? So can I say that approximately it's a same, right? 89.72, this is what we have received last time, and this one is 89.71. So there is not much loss that we have received over here, and same kind of a answer even you will be able to observe from here, from this coefficient, right? So here, what is the meaning of this coefficient? So can I say that if I'm going to invest 1 unit over a newspaper, right, a total effect on my sales will be 1 into this much, which is almost negligible. Yes, which is almost negligible. So actually it's not participating that much. So even if you are going to invest a lot, right? So let's suppose I'll give you like $1,000, right? And now I'll ask you, okay, fine. So can you take a decision to do some sort of an investment on a newspaper, right? What you will do, what you will suggest in that case? You will say that no, what I feel is investment on newspaper is not a wise idea, right? Because even if you are going to invest a lot, but a total changes which it is going to do on your sales is very, very less. And in this case, you are not supposed to make more investment, or even $1 of investment in newspaper. But yeah, you can try to invest maybe on a TV ad, which is very, very effective, or maybe on a radio ad, right? So which is again effective, but you are not supposed to do some sort of an investment on a newspaper, right? It's going in negative direction, as well as changes or impact is very, very less on your final sales. Right? So does negative sales confidence mean sales will decrease? No, it's not. It doesn't mean in that way. So whatever you are investing, so let's suppose if I have done an investment of let's suppose 100 rupees, there is a chances that I will try to receive what 10 rupees out of 100 rupees I'm trying to invest, but 10 rupees I'm able to generate. So in that case, loss will be equal to 90 rupees, right? So here it's not like you are like trying to decrease something by investing. So it's always it simply means that this is the total impact it is going to create. There is a difference. Yeah. Okay. So in this case, what we can do, maybe we can try to consider this particular fact that we are not supposed to consider this newspaper factor. Maybe TV and radio is completely fine. I'll do, or I'll try to make my investment on TV and a newspaper instead of doing some sort of investment on this particular part. Now, this is where a feature selection comes into a picture. Meaning of feature selection is what? A meaning of feature selection is that, let's suppose I have given you 3 features: TV, radio, and a newspaper. And then I'll ask you that, okay, so can you please suggest me what in all features I'm supposed to select so that I will be able to build a model, right? Because it's not like if I have given you a 10 columns, you are supposed to consider all the 10 columns, because there is a very high chances that all the 10 columns are not going to participate in terms of giving you a final result, as you are able to see here in case of a newspaper, right? It's not participating much, right? Its participation is almost negligible. So can I say that I'm not supposed to select this particular feature? Yes. Yeah. So feature selection, we always talk about a feature selection, feature engineering, and a different kind of things, which is again a part of your EDA, right? So feature selection. So here, whenever we have to do a feature selection, so we can try to do a impact analysis, and based out of that, we can try to do a feature selection. In most of the cases, in most of the machine learning cases, you are supposed to know about a business. So unless and until you are not aware about a business, just by looking into a data, or maybe by doing this kind of operations, you will not be able to understand it. So you should understand a story behind a data set as well, as we are trying to understand a relationship between sales versus newspaper. So this is a relation. This is the story. This is the story between newspaper and or sales, you can say. So there are a different way by which you will be able to do a feature selection, right? So there are multiple way by which you can try to select one feature, or maybe you can try to reject a different kind of a feature. Now here, one of these way is, in this particular case, maybe by using r square. But there is a issue, I'll tell you. So by using r square, so what r square does, so r square is telling you that, okay, so if I'm trying to increase a number of feature, your r square is increasing a little bit, right? So if I'm trying to consider all three feature, your r square has increased a little bit, right? So here I have just removed it and it has decreased a little bit, right? So r square is one of the feature or one of the assumptions you can make by which you can try to understand, or maybe you can try to take a decision that whether I'm supposed to consider this feature or maybe another feature, or we are supposed to reject one feature or we are supposed to reject another feature. But r square is not a reliable one. R square is not like where you are supposed to make a complete concrete decision that whether I'm supposed to select it or whether I'm supposed to reject it, right? So here, yes, I'm able to see a very minor differences in between three feature and two feature. So I will try to I will prefer to go ahead with a two feature instead of going ahead with the three feature. In this way, I'll try to end up decreasing I'll try to decrease model complexity, right, amount of the data set, as well as I'm able to get approximately a same sort of a score, which is nothing but r square. So r square is one of the way by which you can try to make this kind of a decision, but this is not everything, right? So there are other way as well by which you can try to perform, or you can try to do same kind of a thing. So let's try to understand all of these things one by one. And now let's try to talk about adjusted r square. So what is the meaning of adjusted r square and why these things are important? So all those things let's try to understand, and then I will be talking about a p-value relation. So what is a meaning of a p-value? I think in your stats classes, so we all have gone through a p-value, right? So here we are going to utilize those p-values, right? And we are going to learn maybe adjusted r square. We will even see where adjusted r square is going to fail, and what in all other operations or other things that we can try to do to perform a similar kind of a operation. So let's try to understand all of these things one by one in this particular place. So here what we can do is, so maybe we can try to go ahead with one of the way or one of the approach called as statistical modeling approach. So here we are trying to use a scikit-learn library to build this particular model, which is completely fine. But there is something called as statistical approach. So we will try to understand that what is a meaning of this statistical approach, and how by using this statistical approach we will be able to perform these kind of a operation. So let's try to understand all of this particular part. Where is my statistical import? Okay, yeah. So here is a statistical import that we are trying to do, right? So import a stats model, and this is a different library. This is the different packages that you will be able to find out. So here is we are trying to use just a statistical model. So we are trying to call what? So we are trying to call SMF, a statistical model dot OLS. OLS is nothing but ordinary least squared model. So there are actually a two-way you all will be able to see to build any kind of a linear regression model. One is by using a scikit-learn library, and another one is by using this OLS approach, ordinary least squared approach. But this is just going to give you a statistical way of doing impact analysis of a model that you are trying to build, or maybe a feature that you are trying to pick and choose. So this is the only thing a statistical model is going to give you. Apart from this, it is not going to give you anything else, I would say. So here we are trying to call a statistical model dot OLS, ordinary least squared, and we are going to execute. Let's try to understand this part. Now here, data is not defined, so it is going to be a data frame. Yeah. So here you will be able to see that it is giving me one set of a table, right? This is the table that I'm able to receive out of this statistical model. Now let's try to understand. So what is the meaning of this one? So it is showing me that, okay, it's a sales versus TV that we are trying to print, or sales versus TV summary that we are trying to print over here. So if we are going to build a model, so where sales is going to be my feature column, and sales is going to be my label column, and TV is going to be my feature column, then this is something that we all will be able to receive. So R square value is going to be 0.612. And yes, so this is the same thing that we have done, right? So 0.612, this is something that we have received. So when we were trying to build a model for a sales versus TV. Now, if we are going to accommodate maybe a TV plus a radio, let's try to understand what will happen and what is the kind of a result I will be able to receive. So what I can do is, so maybe I can try to add over here radio, right? So when I'm trying to add a radio, so in this case, what is the value of R squared? So value of R squared is 0.897. Now, if we are going to do the same thing, right? And we are going to add radio plus newspaper. So in this case, 0.897 is a R squared that I will be able to receive. And yes, this is the same thing that we have received even before, right? So even before, so we have received the exact same kind of things. Now here, just by looking into an R squared, so we can say that yes, sales versus TV is not going to give me a better R square. But if I'm talking about a sales versus a radio plus TV, in this case, I am able to build a better model. This is the same observations that we have done even last time. We are able to receive, but by using a different approach. So here I'm trying to use a statistical model. Now, the difference between a statistical model and your scikit-learn model that you will end up building is that this is not going to give you a final physical version of a model which you can productionize. This is just going to give you some sort of a final model or some sort of a statistics, so where you can try to run your analysis, you can try to understand impact, you can try to understand relations. So this is the only thing you will be able to get out of this statistical model or ordinary least squared model which I'm trying to call. Apart from this, nothing else you will be able to observe. So here, method wise, you will be able to see it's a least squared. Model wise, OLS, ordinary least squared model, it's the same thing. It is trying to understand your relationship, and then based out of that, it is going to give you a result. Now here, so when I have taken sales and a TV, it is going to give me intercept is equal to this much, TV is equal to this much. So can I say that I was able to get a same answer, right? Yeah. So we were able to get a same answer when we were trying to consider TV versus sales. So there was an intercept I was able to get, there was a TV, which I was able to get over here. Now, just try to look into this particular area. So here we are trying to understand a p-value, right? So we are trying to understand a p-value. And what is the meaning of p-value, by the way? So anyone who can tell me what is p-value? Okay, significance label. Fine. So most of you are saying that it's a significance label. It is going to give you. Fine. So here a p-value is equal to 0.0. So can I say that this one, intercept and TB, is a significant one for all of us? Yes. Can we make this kind of a statement that TV and a newspaper is a significant one? Now let's try to understand another table, right? So here for TV, radio, and a newspaper, sorry, for intercept, TV, and a radio, so we are getting p-value is equal to 0.000. So yes, this is significant. Now if I'll start looking into this one, 0.000 and 0.86. Now what is the meaning of this 0.86? Anyone? So what is our meaning of this 0.86? So can I say that p-value always represents a significance label. And in general, if I'm trying to understand, right? So here, so let's suppose I have defined an area. So where this area is 0.05. Now, if something is falling under this area, so in this case, can I say that things will be non-significant, right? Or in other word, let's suppose if I'm trying to do 100 experiment, and out of this 100 experiment, if 95 experiment is going to succeed and 5 is going to fail, right? So can I say that my experiment is successful by a 95%? Yes. So I can say that my experiment is successful by 95%, right? Okay. Now here, p-value is 0.86. What is the meaning of it, right? So 100 minus 86 is equal to what? 14. Yeah. So your newspaper is contributing, right? So your newspaper is contributing, or its p-value or its significance level is very, very low. Can I say that newspaper significance label is very, very low? So maybe I can say that out of 100, only 14 is contributing and 86 is a non-contributing one. Yes, this is the meaning of a p-value that we have understood. I think Chris has taken your classes for statistics and he was talking about a p-values over there. So this is a meaning that I can try to derive out of this one, that out of my 100 experiment, 86 experiment is not contributing, only 14 is contributing, right? This is something, and this is how we can remember, because many of you again, even after giving a classes on a p-value, so I have observed that many of you just get confused. So just try to understand in this way, that p-value always tells you that, okay, how much or how many values are going to fail, or how many experiments are going to fail out of these many number of the experiment, out of 100 for sure, right? So can I say that this is contributing completely, this is contributing completely, right? Because it's a 0.0, right? But here, so out of 100, I can say that 86 experiments are not contributing, only 14 is contributing, and in that case, maybe this is a non-contributing one and I can drop it. Yes. So this is something that we are trying to derive out of this summary table, right? Again, I was able to derive same thing even from our R square, right? Because when I have taken like a TV, radio, and newspaper, and when I have just taken TV and radio, right, my R square was approximately same. Yes, R square was little bit less in case of TV and radio, and in case of TV, radio plus newspaper, it was a little bit high. But here, so but again, so R square was not giving me a concrete answer where I can make a decision. But here, can I say that it is giving me a concrete answer, so where I can make a decision? Yes. Actually, I was trying to do a feature selection. My idea was what, or what we were trying to derive. So I was looking for a feature selection. Simple. And what is the meaning of feature selection? So I have to find out, or I have to figure it out somehow, that which one is contributing and which one is not contributing. So first experiment I have done is with respect to R square, right? But R square was like approximately same in case of TV, radio, and newspaper. So in both the cases, it was approximately same. So maybe I was not able to conclude, right, that whether I'm supposed to eliminate newspaper or I'm not supposed to eliminate a newspaper. So what I have done some sort of a statistical analysis. So I have called a statistical model, which can give me a more number of like a more points for a understanding, or maybe more number of points to make a concrete decision, right? So here I'm trying to compare a p-values. So when I'm trying to compare p-values and when I'm trying to add a newspaper, right, over here, I'm able to find out that newspaper is not contributing out of my 100 experiments. So maybe for 86 experiment it is not contributing, which is very very high out of 100, and only for 14 experiment it is contributing. In only in 14 instances it is a kind of a relevant one, but in case of it out of 186 it's not a relevant one. So can I say that now I can make a final decision that okay, let's remove a newspaper? Yes. Yeah. So here, right, so this is the kind of a decision we were trying to make, and just try to understand a p-value or significance label. So in this particular way, so we always say that if significance label is lesser than 0.05, means 5%. So out of 100 experiment, if 95 experiments or more than 95 experiments are going to support us, so in that case we are supposed to consider that particular feature. If lesser than 95 is going to support us, so maybe in that case we can try to drop. And again, that depends upon my assumption. So if I have taken a 10% of assumption, 5% of assumption, 20% of assumption, depends upon like a cases that we are going to handle. Yes. So this is a kind of a conclusion that we are trying to make out of this. So in many books you will be able to find out that they used to take p-value assumptions is equal to 0.05, means 5%. So they consider that if out of 100 5 is not contributing, 95 is contributing, let's take that particular feature. So let's finalize that particular feature. Let's not drop those feature. Is it making sense? Are you all able to interpret p-values that you have studied in your statistics classes? Yes. So just in a simple way, try to understand it, not just go after the bookish definition. Then you will be able to remember and you can explain things to other people in a easiest possible way. Okay. So fine, no issue. So I think now we are in a place where we can try to make a conclusion, and this is something called as feature selection, right? So we were trying to like work on the feature selection part. Now apart from this, so I'm able to get some sort of a skewness, I'm able to get a kurtosis, or maybe W Watson like a result, AIC, BIC. So there are so many different kind of responses you will be able to see over here. So when we call statistical model on top of any kind of a data, most of the things will be clarified in your classes, in your upcoming classes, as we are going to progress, right? So what is the uses of what, each and everything will be clarified easily, but not at a time. So as you will progress, things will be very very clear. Now here, so it's given as standard error. So what is the meaning of this? Anyone who can explain? Yeah. So anyone who can explain that what is a standard like a error that is given? Okay. So it's basically a standard deviation which is given to you, right? So when you are trying to talk about intercept, TV, and radio, so what will be a standard deviation at any point of a time? So this is the result, but again, this is not a result which is going to help us in terms of making some sort of a conclusion. So a result which is helping me is a p-value, and that's the reason. So we are just talking about a p-values so that I will be able to fulfill my objective. Okay, no issue. Now here, so apart from this, you will be able to see some values called as adjusted R squared. Now let's try to observe one of the interesting fact over here. So adjusted R square is 0.61 in case of TV, only TV feature that when we have taken. When we have taken TV plus radio, at that point of a time, it is 8.96. And when we have taken TV, radio, and newspaper, even at that point of a time, it is going to be 0.896. Again, if you are going to expand it, you will be able to see a differences. For sure, you all are going to see a differences if you are going to expand a same thing. So here, what is a meaning of this adjusted R squared? Let's try to understand this particular part and how adjusted R square is different from your R square, and where and in which case we are supposed to use R square or maybe a adjusted R square. Let's try to conclude even this particular part because this is very, very important. And again, many people are going to ask you a question or confuse you on this particular part. So here we are getting two results. One is a R square and another one is a adjusted R square. Now here you will be able to observe that if we are going to create or if we are going to take a more number of maybe columns or features, in that case you can see there are some changes or there are some increment you will be able to see in case of a R square, but it is not a reliable one. If my R square is increasing, right, that doesn't mean that I'm trying to increase an accuracy of a model. Maybe my model is going to be a overfitted one. There is a very high chances that my model is going to be a overfitted one, because we all have seen in case of a newspaper, it has increased a little bit, right? By 0.001%, it has increased. But that doesn't mean that whatever model which I have built, it is going to give me a better outcome or better result. And this is where adjusted R square comes into a picture, right? So why adjusted R square comes into picture? Because R square was increasing. So what I will feel is that my model is getting more and more accurate. But no, that is not true. We all have seen that in case of a newspaper when we have added. So in that case, R square is not a reliable matrices by default to give me a correct decision about a score or maybe about a things that we are trying to do or we are trying to perform. So here in this case, we are looking for something else something else which is much more robust or accurate than a R square. And this is where adjusted R square comes into a picture. So let's try to understand what is a actual formula of adjusted R square, right? So if I'll talk about the actual formula of adjusted R square or this one, so this is going to be 1 minus R square n minus 1 divided by n minus p minus 1. So this is a formula for adjusted R square. What is the formula for R square? So 1 minus RSS divided by TSS, residual summation of a square divided by total summation of a square. This is something that we have studied in our previous classes. Okay, so here adjusted R square is, yes, by default it is trying to take R square, right? But what about this P and what about this N? So here P is nothing but a number of predictors and N is nothing but a total number of a row or total number of the sample that you are going to create. So here P is going to contribute or it is going to penalize based on the number of predictors or maybe x1, x2, x3 and so on. And N will always depends upon the number of a rows. So if number of data set is equal to 100, so yes, it is whole data set or whole adjustment is going to change itself. Now, why this factor is been added over here, right? Because we all know that if we are going to add more and more amount of our data, right? If we are going to add more and more amount of a row or more and more amount of a data, so for sure it is going to affect my accuracy. It is going to impact my accuracy, maybe by huge volume or maybe by a minor like a fraction. So it is going to impact, but yes, it is going to impact. If we are going to increase a number of the feature, so again it is going to impact. But the matrices that we were using in case of a R square, right? So nowhere we have featured or we have accommodated either a column, variation of the column, or variation of the number of rows, which is not a, that's a reason. So by default your accuracy will keep on increasing. So if number of columns is going to increase, and at the end of the day, so you will end up getting overfitted model. So this is where adjusted R square comes to the picture. So it says that okay, so don't worry, I'm considering even of increase increment in your rows as well as a number of a column. So I'm considering all of this factor, and based out of that, so I will try to give you a result. I will not just give you a result based on RSS and TSS. Yes, RSS and TSS will be involved because residual summation of a square and a total summation of a square is a actual matrices. But what I will do is I will try to consider your increment in number of rows as well as number of the column. And this is where N and P comes in between, right? So N is nothing but number of the data set or number of the rows or number of the like a total data instances that you have given, and P is nothing but your number of the predictors or number of the columns that you are going to give. So based out of that, it is going to give you a final accuracy. So adjusted R square says that I will be able to give you a more reliable result as compared to a R square. So I'll not give you unnecessarily a overfitted kind of a result at any point of a time, and you can have a faith on me. So this is where, and this is something that we all have to understand or we have to like know. If value of P is equal to 0, right? If value of P is equal to 0, so n minus 1 will cancel out, right? And in this case it is just going to be a R square, right? So n minus 1 if like a number of column is equal to 0, so you all can equate. So going forward, whenever you are trying to build a linear regression model, so instead of calling R square, always try to call adjusted R square to get a better accuracy matrices. So again, both are going to give you accuracy matrices, but adjusted R square is nothing but just a best version of, you can say, it's a R square, which is not going to give you a overfitted result, or maybe it's not going to give you a overfitted unnecessary data set. So is this things fine to everyone? So where adjusted R square comes into a picture, and what is the significance of like adjusted R square? Only in linear models. Yes, only in linear model you are supposed to use it. Yeah, even for adjusted R square. So just like a score, it's a function which is available, ADJ. Now, so moving ahead, right? So now let's try to understand. So I think we have discussed about a feature selection, right? So how I will be able to do a feature selection in case of a linear model. So maybe I can try to go ahead with R square. Maybe I can try to go ahead with P values, right? So which I was able to receive out of your statistical model. And based on that, so I can try to select some of the feature, or I can try to decide that, okay, fine, so which feature is contributing by what kind of a volume. But best again, so there are a different kind of a feature selection method which is available. So again, going forward, we'll try to understand those things. Cross validation is one of the best one that we all can use for doing any kind of a feature selection, but we will try to understand all of these part maybe in a future classes. Now let's try to understand, right? So let's try to understand some different instances of this one. So there is something called as multi-collinearity. So when we were talking about this entire things, right? So this entire linear regression theoretical part. So I think I have highlighted one of the point called as multi-collinearity, right? So multi-collinearity is one of the factor that we all are supposed to understand. Now, what is, by the way, what is a multicollinearity? A multicollinearity is nothing but if there is a relationship between feature and feature, you are able to find out, that is something called as multicollinearity. So let's suppose if I have drawn a graph of maybe a TV versus sales, right? So if this is a kind of a graph which I'm able to get where TV is increasing, sales is also increasing, and sales versus TV looks like this one. In this case, I can say that TV and sales is basically a multi-collinear feature. Means at some point of a time, sales and TV, so both is related. Now I'll give you another example. I think I have already given this example. So 1, 2, 3, 4, 2, 4, 6, 8. So can I say that X1 and X2 is both is same? Yes. Can I make this statement that X1 and X2 is same, right? So both is trying to represent a same kind of a relation. Now, why to take this kind of a relation? So why to take like a two columns? So instead of taking two columns, X1 and X2, maybe I can try to take one, or maybe a hybrid column, right? Maybe I can try to take only one column, because here I'm not supposed to take any columns which is having a relationship in between, a high or huge impact, high impact relationship in between in a feature. What I'm supposed to do, so I'm supposed to take only those kind of a data where it is showing a relationship between feature and a labels, not between feature and feature. So if there is a feature, if there is a relationship between feature and feature, so that kind of an instance is called as multi-collinearity. So there is a way, there is a procedure by which I can try to check that what is multi-collinearity, and there is a way to take a decision or to handle this multi-collinearity. So one way is try to draw a graph. Try to draw a graph and then try to check that whether there is some multi-collinearity between a data set or not. And if you remember, right, so pandas profiling we have called, and in case of a pandas profiling, right, so in case of a pandas profiling, we were able to get a graph. This kind of a graph we all were able to get, we all were able to see, right? So here, if I'll try to check a newspaper versus, right, newspaper versus a radio. So what is a collinearity? What is the meaning of this Pearson graph? So can I say that newspaper versus radio will come somewhere over here in this particular place, right? In this particular place, and this is been represented by what? So this has been represented by a light blue color, right? This has been represented by a light blue color over here, and somewhere in between this to this range. Can I say that? So what is the value of this particular place? Maybe 0.3 or something like that I will be able to get as a value. Yes, so 0.3, 0.4 is the value I will be able to get for this particular place. 0.30 or something like this I will be able to see. Now why I'm talking about this number? So there is a reason behind this discussions, or there is a reason behind this particular number that you all will be able to see, and you will be able to observe that this scale is fluctuating from -1 to +1. Again, there is a reason behind this one. That's the reason. So it's like a fluctuating in between -1 to +1, right? So here, this is a Pearson graph. Again, so you can try to do experiment test or candle test or maybe fig test. You can try to do everywhere. You will be able to find out exact same kind of things. Now here, if I'll see, so newspaper and radio is one of the feature, right? Now radio versus maybe radio versus newspaper, same thing. Radio versus TV, somewhere over here, some here, radio versus TV. This is the radio versus TV. So what can be the value? Approximately close to 0, 0, right? So here it is trying to give me 0.3. Here it is trying to give me 0.00, approximately, approximate result, right? And this whole scale is ranging in between -1 to +1. This is the range of this entire scale. So the conclusion over here is that I'm trying to find out a correlation between, or how collinear this entire things is. in between, right? So how one is going to impact others. So can I say that everywhere, whether I'm going to look in this direction or maybe in this direction, so everywhere, so TV versus sale if I'll see, radio versus sale if I'll see, newspaper versus sale if I'll try to check, right? So this value will come somewhere in between, this value in between, right? This value somewhere in between. So it is representing our relations, how strongly things are connected. Yes, so it is just trying to represent a relation, so how strongly a things is connected over here. So it's going closer to +1, almost closer to +1. But if I'm talking about maybe a TV versus radio, or maybe if I'm talking about newspaper versus radio, so here color is a faded one, means on top of the scale, if I'll talk about this color, so it's giving me a very less kind of a values. Now it simply says that this is how this entire data set is correlated with each other. This is talking about just a correlation. So where correlation range will be in between -1 to +1. So now in Pearson test, right? So -1 to +1. So if there is something which you are able to get, which is correlated more than 0.9% or more than or lesser than 0. -9%. So in this case, we can say that these things are highly correlated. This is what it is trying to explain. That if there is something which is having a value more than 0.9%, right, 0.9 or lesser than, you can say like a -9%, so in that case, or if it is closer towards this direction or this direction, things are more correlated. If something is falling in between, so maybe we can say that it's not that much of like a correlation we have in between, right? So if relationship between radio and TV is very high, right? If relationship between a TV and radio is, let's suppose, closer to 1, right, of maybe 0.9, 0.95. So can I say that in this case, relationship between radio or explanatory features between a radio and a TV is very high, and in this case these two, because radio is also a feature column and TV is also a feature column, so can I say that both are multicollinear? Yes. So we are trying to check that, okay, fine. So whether there is some multicollinearity is just a name or just a term, which simply says that if there is a relationship between, right? So if there is a relationship between a column like a x and x, in that case it's called as multicollinear situation. But again, here in this particular graph, I'm trying to find out a relationship with all the like a data set with all other data set. Very simple, right? Maybe I can try to select some of the columns, feature column, and then I can try to plot this kind of a graph, Pearson graph, and again I will be able to see the same thing. So if there is some column which is showing a values more than 0.9% or lesser than -9%, 0.9%. So in that case, I can say that those two features are highly correlated, or there is a multicollinearity in between. And in that case, you have to handle it. You have to drop it, or maybe you have to do some sort of a treatment, or some hybrid column you will have to create in that particular case. Yes. So here someone is saying that TV, radio, and TV and newspaper are multicollinear. So TV and radio. So how this is multicollinear? This color is white, right? So this color white is represented where? Can I say that on a this place, 0.00 place? So the value is what? Value is 00. I said that if it is closer towards +1 or -1, is it closer towards +1 or -1? Yes or no? No, right? Now, if I'll talk about newspaper versus radio, so this is the value, right? This is the value. So this value will range in between what? Hardly 0.25 to 0.5. In this range, this is going to fluctuate, right? So can I say that newspaper, radio versus newspaper is again not multicollinear? Yes. Yeah. Now someone is saying TV versus sales. What is a definition of multicollinearity? First of all, try to recall that one. So multicollinearity is not identifying a difference between or collinearity between a feature and labels. So can I say that your sales is a label column? I'm just trying to, that's the reason I have clearly mentioned that multicollinearity is just a term, right? I think some of you are not able to get that particular point, or maybe you were sleeping when I was talking about this line. So try to understand that multicollinearity is a term, right? Which a term which we can use with respect to a feature. So now some of you are saying that TV versus sales, right? This is, so yes, it can be like a close to 0.9 or like a close to +1, but this is a label column. This is a feature column. It's completely fine. This is the expectation, right? This correlation is just trying to explain the complete relations. Let's suppose what I will do is, so in my data frame, so I'll select just 3 columns: TV, radio, and newspaper, right? So in that case, you will not see these relations. Simple. So remove it and call again a Pearson graph. Yes, everyone? Yeah. So multicollinearity always, like whenever we talk about multicollinearity, we always talk about feature versus feature, not feature versus sales. So that's the reason. So I clearly mentioned, right? This is completely fine. Okay, fine. I think most of you are able to get the points. Okay, now, so multicollinearity. So whenever we have to, that's the reason. So we have a Pearson graph. So I think all of us are able to understand the Pearson graph. Yes. So maybe last time we were not able to discuss about that particular part because we were just talking about the basic of integration. Now things are getting clear, right? So fine. Okay. So here, simple. If you are able to get some sort of like a multicollinearity in between, or some sort of a relations in between, like more than 0.9%, lesser than minus of 0.9. So in that case, remove it, or maybe do something, right? So I'll tell you what and all things you can do. There is another way to find out a multicollinearity, and that is something called as VIF, variance inflation influence factor, right? So let's try to understand. There is something called as VIF. Again, this is another way. You can try to either of these ways. Pearson graph you can try to use, or maybe you can try to use this one. So this is a formula for variance inflation factor. Variance inflation factors. So here, right? So variance inflation factor, we are trying to use what? So we are trying to use 1 by 1 minus adjusted, R square, right? And we all know that what is the R square? R square is nothing but it's just residuals, right? So it always tells you that how close your line is with respect to a with respect to our data points. So here, variance inflation factor, if it is greater than 10, right? If VIF value is greater than 10, in that case, you are supposed to consider like a data set as highly collinear. If VIF is greater than 10, right? So in that case, you are supposed to consider, or you are supposed to say that my data set is highly collinear. Now let's try to understand a situation that when your data set is going to be 10, or when VIF is going to be 10. So can I say that if I'll start looking into, right, if I'll start looking into this equation, so 1 by 1 minus 0.9 if I'll give, right, 0.9 if I'll give, in this case it is going to be 10. Agree everyone? If R square is 0.9, so in that case, can I say that it is going to be 10, right? And let's suppose I have taken two feature. Again, I'm talking about just a multicollinearity. So I'll talk about feature versus feature. So don't try to think in terms of feature versus label, right? So let's suppose I'm trying to build a model, right? So where I'm taking TV versus radio. I'm not talking about sales. Again, sales is my label column. So I'm supposed to find out that how collinear these two things is, right? Because when we are trying to talk about a TV versus sales, what we are doing? We are just trying to draw the line. Yes, because we think that there is a relationship between TV and radio, TV and sales. So similarly, we can try to draw a line in where like a TV versus radio. We can try to check that out, that how a strong relationship is there in between TV versus radio, right? So if I'm trying to draw a line, right, TV versus radio over here, and if this line is going to explain 90%, meaning of 0.9 r square is what? That a line that you have drawn is able to explain a 90% of our relations. Yes, everyone, don't sleep. Yeah. So yeah, so it is able to like explain a 90% of a relationship in between TV versus radio. So can I say that there is a very strong relationship between TV and radio if r square is 0.9? Yes, I'm talking about TV versus radio. Forget about your level column. I'm talking about feature versus feature. I'm talking about multicollinearity over here. Yeah. So if there is a very high relation, so in this case VIF will become 10. That's the reason we used to say that if it is greater than 10, in that case remove it. So can I say that we are talking about a same version in different way? I think in case of a correlation, more than 0.9 is going to tell you the same thing. Yes, so just terms are different, right? Or this one is terms are different, but yeah, so we are actually talking about the same thing, and VIF is nothing new, right? It is again based out of what? Just a relation, just r square, right? And we all understand r square now. And how do we calculate r square? What is the meaning of r square? What is the meaning of residual? So all of these things we understand, right? So that's the reason it's called as that if VIF is greater than 10, right? If VIF greater than 10, in that case, we are supposed to do some sort of a treatment, a very simple one, right? So maybe we can try to remove one of the column. There is something called as dummy variable trap. So I'll be talking about a dummy variable trap. Maybe some of you are aware about this particular like a name called as dummy variable trap, but maybe most of you are not aware about it, right? So I'll be talking about a dummy variable trap. Again, dummy variable trap is related to this one, the things which I'm trying to talk about as of now. So I'll discuss about dummy variable trap in that particular sense. But if I'll ask you a question, how to identify that whether there is a multicollinearity or not between a data set, what will be your answer? So yeah, I'm just reading, I'm just looking at your like chat. So yes, you are saying that like try to do a correlation plot, right? Pearson plot, experiment plot, Fick plot, we can try to do. By that we can try to identify, right? So in case of a correlation plot, if your values are more than, if correlation values are more than 0.9 or lesser than minus 0.9, in that case there is a very high correlations. Feature versus feature, again remember this particular part. Or else what you can do, so you can try to go ahead with the VIF calculation, right? So where again it will take 2 column, 2 feature, combination of 2 features, and then it will try to calculate what? R square. Then it will try to calculate what? VIF. If VIF is greater than 10, it simply means that R square is greater than 9. Means this data set is able to explain itself more than 90%. In that case, there is a high correlations. So these are the way by which you will be able to identify that whether we have a multicollinearity in our data set or not. And if we have a multicollinearity, right, then what we are supposed to do. So in case of a multicollinearity, because we all understand what is the meaning of multicollinearity, so maybe we can drop one of the column, right? So let's suppose TV and radio is showing a very high multicollinearity. So maybe I can drop either of them because both of them are going to explain the same kind of relation. So there is no meaning of keeping these things. Or else, so you can try to ignore it if it is like a manageable, maybe lesser than 9%, right? Or you can try to do some sort of a dimensionality reduction technique, PCAs or LDAs. So PCA is something which I will be discussing about maybe in your future classes in a beautiful way. PCA is a kind of important topic, but like a kind of like a complex things to understand, complex topic to understand. It's a mathematical, it's a heavy topic, you can say. And generally I like give 3 to 4 hour lecture just on PCAs to explain only one topic approximately. Yeah. So yes, so PCA or dimensionality reduction is one of the way. Maybe we can try to drop immediately, or there is something called as dummy variable trap I can try to remove, and in this way I can handle a multi collinearity. So I think we are clear on feature selection, how we can do a feature selection. Yes, everyone. I think we all are able to understand a multicollinearity. Yes, I think we all are able to understand third thing called as multi-regressions and multi-linear regressions. So linear regression we have understood, mathematical concept we have understood. So these three topics, I think we all are clear on this particular part. Now I will be talking about another topic called as regularization, right? So what is our meaning of regularization and all those things, and VIF also. So whatever this topic which I have discussed, right? So I'll try to show you, or I'll try to like talk about like a programmatically. I'll show you like a different like a things, or I can say how we can try to calculate a VIF and all those things. It's very easy. It's not at all like a difficult to calculate like a VIF at any point of a time. So we'll be talking about it. Don't worry. But yeah, so let's try to talk about a third topic, right? Theoretically, which is called as a regularization. So what is a meaning of regularization? What is our importance of regularization? Let's try to understand that particular part, because implementation very quickly we will be able to do. Just you have to understand theoretical and mathematically everything. That's it. And even in interview, so these things are very important. People will ask you like a direct question on this part. That's the reason. Okay. So another topic which I'm going to discuss now is called as regularization. I think spelling is correct. I make lots of mistake in spellings in general. Regularization. Yeah, it's correct. Okay, fine. So what is a meaning of regularization? So, and how many different kind of regularizations are possible, right? Or it's available, how I can try to implement it, right? So we have to get all of these answers. Anyone who is having any idea what is realization, why it has been used? Yes. To reduce our biases, someone is saying, for reducing our variances. Just give me a very simple answer about realization, a layman kind of answer which I can understand. Process of removing overfitting. Okay. It is used to get a best point in between overfitting and underfitting to reduce a multicollinearity. Okay, amazing answer. A completely wrong one. The act of bringing a uniformity. Okay. Penalized. Okay, so I think most of you are giving me a bookish answer. So I'm not expecting a bookish answer. I'm not a person who likes bookish answer. Because what I believe is, if you are giving me a bookish answer, it simply means that you are not able to understand. This is what I like believe always. So in interview, if some person is like just giving me some like some sort of answers which is already written in some of the books, right, or maybe somewhere, so I don't like accept those answers. Simple. I simply reject those answers. Why regression is important? First of all, try to understand that part. I'm just like looking at your answer. So yeah, keep on typing. Okay. Okay, just tell me one thing. Right. Forget about this definition. Forget about this realization. Just tell me one thing, right? let's suppose I have built a model, and maybe I'm like able to get a overfitted result. Overfitted means what? Overfitting means what? I think we all know about it. So let's suppose at the time of training, my model accuracy is, let's suppose, like 90%, and at the time of like testing, so it is giving me maybe a less percentage of accuracy, right? So that is a situation so where I have end up building a overconfident model, or it can say overfitting, right? So overconfident model maybe I have built, or I have created, or like a overfitting I have done over here. My model is like a overconfident at the time of like a training, and when I have tested it with the outside data set, so maybe it is not giving me that much of accuracy. Why these things happens in general? So this things happens because so model is trying to adjust its weight, or in other word I can say that if I'm talking about y is equal to mx plus c, so can I say that my accuracy will always depends upon m and c, the way I have selected m and c, so it will always depends upon m and c, right? The way I'm selecting m and c. Now here m and c is nothing but you can say maybe a weight and the biases, or m and c, just keep it in this way. Yeah, because just because of that, so I'm like I'm trying to say that okay fine, so I have built a stable model, or maybe overfitted model, or maybe underfitted model. This is the only reason. M and c is the only reason in this particular situation. Now how do we adjust a value of m and c? So can I say that we try to adjust a value of m and c by taking a differences in between, or based out of the errors or cost that we generally receive. And what is that? So that is nothing but difference between y and y hat. So can I say that that is something called as error, right? That is something called as error. Difference between y and y hat is called as error, right? So based on y and y hat, so we try to adjust a value of m and c. Agree or disagree? Yes, agree everyone? Based on it, so if y and y hat difference is very high, so maybe I'll try to adjust more. I think this is what we have discussed in our d by dm and d by dc. Yes, this is what we have discussed, right? And 3-pen concept I have shown you. Yeah, so this is what we have discussed, like a d by dm or d by a dc, and based out of that, so we try to adjust values of m or c. Yeah, so our whole idea and objective is to come over here, which is a minima point where d by dm is equal to 0, d by dc is equal to 0. This is a point we always try to achieve. If error is high, in that case, for sure, changes will be high. Agree, everyone? So m new is equal to nothing but m old eta delta E of m. This is the equation that we have seen. Yeah. What is the delta EM? So can I say that this is the error? Delta EM is nothing but it's an error that we used to receive. So if error is high, so can I say that your whole changes will be high? Over here, yeah, changes will be high. Okay. So now I have some data set. There is a situation, right? So I have some data set, so where error is fluctuating a lot, right? Above and below. So sometimes I'm able to receive some sort of a data set which is producing a less like a differences in between y and y hat, and some sort of a data set, some sort of a record that I have which is producing a more amount of a differences in between y and y hat. Yeah. So I have to control this kind of a changes, right? So I have to control this kind of a changes. So to control this kind of a changes, I already have a eta. Eta is nothing but a learning rate, right? So I already have a eta, because whole changes just depends upon, or your model is going to overfit or underfit. It depends upon your value of m and c, and the way you are like adopting a value of m and c. So people have proposed that why can't we penalize, right? So why can't we penalize this total changes? Why we are giving this much of freedom to this particular changes, right? So let's do one thing. Let's try to control these changes. So if I will be able to control these changes, So it will be able to generalize it more and more. Is this statement true? So if I'm saying that, okay, so if I will be able to control, right, the way, or the way it is trying to move, or the way it is trying to change a value of M and C, I will be having more control over a relations. Is it true? And I will be able to generalize my entire model or entire relations in a better way. Now, to control these things, people have added, or they have decided that, okay, fine, so let's try to use something else over here. Let's try to use a technique called as regularization, by which what I will do, so by which I will try to control a total changes, or I will be able to control maybe a error term, right? Or error term I will be able to control. So I will be able to control a degree of freedom of M and C, which we have over here, the way it is changing. So I'll not allow to change. So I'll always try to, because what is called as best model. So let's suppose I'll give you like a example. I'll just give you an example. So there is a model which is having accuracy is equal to 90%, and there is a model which is having accuracy is equal to 60%. Now, which one is the best model? Many of you are saying actually 90%, but you should not say that. You should actually ask a question. I think some of you have already like written these things, right? Actually, you should ask a question over here that, okay, 90% accuracy you are able to get, 60% accuracy you are able to get, right, at the time of training and initial testing of the model. But what is accuracy it is trying to give you on a regular basis when you are trying to test it with the unknown data set? Now I'll try to give you one more additional input for the same question, right? So for this model, let's suppose M1, and for this model M2, for this at the time of training 90%, and then 85% is the accuracy it is trying to give me on a test data set. And this one is giving me 61% or 59%, right, at the test data set. Now, which one is the best model? M1 or M2? Your answer has changed. Many of you have changed your version. Last time you were saying that it was like a 90%, and now you have started saying that it's a 60% model, which is a better model as compared to this model. So model, whether model is a best model or worst model doesn't depend upon your initial accuracy. This is what I was trying to explain. A model which has generalized itself. See, in second case number 2, model 2, right? Accuracy is 60%. So it is trying to claim that, okay, out of 100 data set, for 60% of 60 data set, so I know I'm able to understand a relationship, right? Whereas model 1 is saying that, okay, fine, so out of 100 data set, for 90 data set, I'm able to understand the relationship. But when I'm trying to give like an extra data set for a testing purpose, right, at that point of a time, so it has already claimed that, no, I will give you 90% result, and now it is claiming that, no, I won't be able to give you like a 90%. So now I can only understand 85%. Tomorrow, maybe it is going to be like a 80%, day after tomorrow, 75%. So can I say that model number 1 is not able to generalize on top of the claim that it is trying to make? But at the same point of a time, model number 2, right? So can I say that it is claiming 60%? So at least for 60%, right? At least for 60%, it is able to generalize. Can I say that? Yes. So model, best model or worst model doesn't go after the accuracy. Generally, people, beginners, I have seen almost all the beginners, right? They always go after the percentage of accuracy. Percentage of accuracy is not a real thing. Believe me, you will be able to understand soon, like maybe like a later stage, right? when you will actually like start working on the actual projects. Yeah. So what I was trying to say over here is that regularization. So regularization is something that we were trying to understand. Yeah. And here, whether I'm talking about this instance or this instance, all of these things depends upon value of M and C. That's it, right? Now, value of M and C that we are trying to find out, that depends upon error term, difference between y and y hat, so cost function, right? So more control if I will be able to get over here, right? So more generalized way, I will be able to produce this M value, because this is something which is telling me the relations, right? So controlling these things, error term, so that I will be able to generalize my model in a best possible way is called as a regularization. Is this definition clear to everyone? Yes? Yeah? Okay. Now, to like regularize anything, right? So there are different technique. You can derive your own technique as well. It's not that tough, right? But yeah, after like experiments. So there is something called as L1. There is something called as L2. There is something called as elastic net, right? So we will be talking about these kind of a regression technique one by one. So let's try to understand what in all regression technique that we have, and then we can try to discuss. Yeah. So there is something called as lasso. Least absolute shrinkage and selection operator. This is the name. Least absolute shrinkage and selection operator. This is the name. This is one of the regularization technique, you can say, right? So least absolute selection, shrinkage and selection operator. In other way, it's called as L1. L1 form. It's called as L1 regularization. Simple. Now, what happens over there? So I think we were able to understand the definitions of regularization, like controlling the total changes into MNC or degree of freedom of MNC by controlling the error term, because that is something going to explain or generalize things in a better way. Because at the end of the day, my objective is to do only one thing. My objective is to build a generalized model, a model which can explain a variance into a data set. That is the only expectations that I will be having, right? So I have to control like a changes, or I have to control a degree of freedom of something which is going to define this kind of a relations. Yes. So here is a thing, here is one of the things, lasso or L1, which is going to be one of the regularization technique. Now, formula wise, if I'll talk about this regularization, so it's nothing but residual summation of square plus lambda of summation of, I can say, beta of j, where j is equal to like a 1 to n. So this is something called as L1. Now, what is this RSS? So can I say that it's nothing but a residual summation of a square, or it is nothing but y minus y hat of a square? Agree, everyone? Yes. So can I say that this is nothing but it's a cost function, or it's a total error, or it's a loss? Yes. So I'm trying to control what? I'm trying to control a changes into error, basically. So I'm trying to control changes into error by adding some of these factors. So where lambda is nothing but it is a shrinkage factor. So what is a full form of lasso? So it's nothing but least absolute shrinkage. So lambda is nothing but it's a shrinkage factor. You will be able to find out. So here it simply says, right? So here it simply says that, and beta is what? So beta is nothing but, so you can try to say m. So in other word, so you can try to like say this one as a m, right? So m1, m2, m3 that we used to write, right? So we can say that okay, so your error doesn't only depends upon y and y hat. So let's do one thing. I will try to keep some of the additional factor of m. This is m. M is, it's the same m. Y is equal to mx plus c. So this m, which is trying to represent our relations, right? So its equation says that okay, why you are calculating just a error difference between y and y hat. Let's do one thing. So try to add some of the factors with respect to m. Why it is important, right? So let's suppose I had m minus 1 and I'm trying to generate m, then m plus 1 I'll generate, m plus 2 I'll generate, I'll keep on attending, or I'll keep on generating a new m, right? So whenever I'm trying to generate a new m, so maybe or whenever I'm trying to calculate a next error, based on that I will try to make some changes into a final m, right? So let's do one thing. So let's try to consider even a previous m that we have already calculated, right? Or summation of all the m's, summation of all the m. That's the reason. So summation symbol, right? So summation of all the m that we have calculated, right? And try to take some of the changes even from there. Are you able to reach out to that point? So it's called as regularization. So I'm trying to regularize the changes. Changes of what? Changes of m. So I'm just trying to say over here that okay, so whatever next m that you will produce, it should also depends upon the previous m and its changes. So you are supposed to take sum of the fraction, right? So sum of the fraction. So don't try to change m drastically or immediately by any values. No, you are not supposed to make a immediate changes. So sometime what will happen is, if error is very high, so can I say that it will try to make more changes? If error is low, so it will try to make less changes. Agree everyone? Just in case of an error, right? What will happen? So can I say that it will try to do some sort of a, like sometime high changes, sometime low changes? But no, we are not allowing it to do that, right? So what we are trying to do over here, so we are saying that no, try to consider previous changes, and based out of our previous changes, try to change something in only in that ratio, right? This is something called as L1. So lambda is nothing but it's a shrinkage factor. So this is a region is called as least absolute shrinkage and selection operator. Yeah. So this is L1. Now let's talk about a L2, right? So there is something called as risked regression. This is called as L2. Now L2 says that okay, right? Here you must be able to see a modulus symbol, right? So whatever m value you are going to give, so it is going to be a positive one. So positive means like it is just going to consider the previous changes. That's it. Now here there is something called as L2, right? Now L2 formula wise, right? L2 is nothing but same residual summation of square y and y hat differences, right? Plus it is going to be lambda, which is again your shrinkage factor, right? So by what volume it is supposed to shrink, and here you will be able to find out same, this beta is nothing but it's representing a m, right? So this is the like a formula you will be able to see everywhere. J is equal to 1 till j is equal to n. Now here beta is equal to m again. So here we are trying to do beta square or m square, right? So here we are trying to do m square. So this says that what I will do, so I will just try to square it up, right? So I'll try to square it up, and I'll try to again like regularize. Now, what is a differences you will be able to find out in both of this? So if you will try to observe these two mathematical operator, you will be able to understand a differences. So let's suppose if my value of m is equal to, right? So if value of m is equal to 10, so can I say that this will be 10 times of this factor, this or lambda factor, and this is going to be 100. Agree everyone? Yes. Okay, fine. Now if a value is 0.1, so can I say that this will be 0.1 times then lambda, and this is going to be 0.01 times lambda. Yes. Okay. Now why I'm talking about these two instances, right? These two data instances. So when m value is very, very less, right? When m value is very, very less. A previous m value is very, very less. So a lambda is a constant term, by the way. Lambda is a constant term. So when m value is very, very less, right? So in that case, whether I should use L1 or L2. So can I say that when m value is very, very less, when there is a very, very less relations, right? Or very like a less changes which we have made last time, right? So in that case, I'm supposed to use L1, but I have to control, by the way, right? So I have to control by the way. So can I say that L1 will be able to get a less penalty, right? Whereas L2 is going to give you like a L1 when value is very, very less, right? So in that case, penalty for L1 is 0.1 times this one. Penalty for L2 is nothing but so 0.00 times a lambda. So means it is not going to make a more number of changes. So here, right? So you will be able to find out that a ridged regression shrinks the coefficient for this ridge regression. So for a very low value, right? So for a very low value, which is having a very low weights, right? So ridge regression always try to give you a very less impact. If weight is very less, it is going to give you a very less impact. Whereas lasso is going to give you a high impact when weight is less or m value is lesser. In case of, right, so in case of high value of m, can I say that wrist is going to give you more control as compared to a lasso, right? So as compared to a lasso, but sometime you will be able to see high value of m, sometime you will be able to see a low value of m, right? So maybe both of them is going to fail or both of them is not going to work. So people have done one thing. So they have experimented with a new technique or new relation technique. So where I will be able to penalize an error or I will be able to control a changes into m even if value is very high or value is very less. I'm talking about a value of m. And this is where elastic net comes into a picture. So elastic net definition wise or formula wise is little bit complex, right? So if I'll talk about elastic net, so this is how a formula like this is how you can try to represent actual formula over here. So elastic net says that it's nothing but so y minus I can say y hat of a square. It's not exactly a y hat divided by twice of n plus lambda 1 minus alpha by 2 summation of beta square plus alpha of summation of beta. So can I say that this factor is more like a raised L2 and this factor looks like a L1? Can I say that? This looks like L2 and this looks like L1. Yes. So can I say that? And this looks like y minus y hat means your RSS same, right? Divided by 2 and so total number of a data set. So here what people have done that, okay, fine. So somewhere it is penalizing more, somewhere it is penalizing less, right? So maybe it is not going to like work for me in a perfect way. So let's do one thing. So let's try to derive the new one. So where it will try to maybe control both the things, or it will try to bridge a gap between wrist and lasso. So here they have introduced one new parameter called as alpha. So alpha is nothing but it's a mixing parameter between wrist and lasso. So alpha value can be a 0. So in that case, if alpha will be 0 over here, so in that case what will happen? So alpha will be equal to 0. So in that case, can I say that this entire factor will be 0? So it will become raised, and if alpha will be equal to 1, so can I say that in this case this factor will be 0, so it will be become lasso? Yes. So behavior will change automatically as and when it is like a required. So this is where elastic data work mechanism wise both is same, right? So it is just trying to control your error part. It is just trying to like control your degree of freedom of changes that you are going to make between M and C beta and biases. But at the same point of time, so it is trying to control the drawback of L1 and L2 as well. It's a combination of both. That's it, right? So this is something that you will be able to find out, right? So by mean M only, right? Yeah. So beta is always like equal to M. So this is the three technique of regularization you all will be able to find out. So if you will try to read out a book, you will be able to find out that it's always advisable to build a model with regularization. So far, so forth, we all have built a model. But what we have done, so we have built a model without regularization. We have not used any kind of a standard technique. We have just taken our data and then we were trying to build a model. But now onwards, when we'll start building a model, what we will do, so we will try to perform a regularization as well. We will try to implement some sort of a rigid lasso or maybe elastic net, and based out of that, so we will try to build a model. Because what we feel is that if you are going to use a regularization, you will end up getting a robust model, a stable model, right? So if someone is going to ask you a question that, okay, how you will be able to build a robust model or a stable model, what will be your answer? Your answer should be that I will end up using maybe, or I'll try to use a regularization, and by using that, I will try to build a model, maybe a stable one or maybe a best possible one. So yes, this is all about your regularization techniques. So today we talked about a couple of things: feature selection, right? Multicollinearity, and I think regularization we have discussed. And what else we have discussed today? Statistical approach, right? So OLS. So these are the four topics that we have discussed. All of this four topic is very, very important as far as your interview is concerned, right? So if you are not aware about all of these four topics, so for sure there is a very high chances that you will end up missing out like many questions. So please make sure that you learn these topics in a best possible way. Um, yeah, some of your friend Sabyasachi, so he has already typed each and everything what we have discussed in today's class, and this is the note for you, right? But which relation technique to select? So if you will ask for my advice, I'll simply go ahead with elastic net. Yeah, I tried a lot but could not understand the hyperparameter tuning. So I don't think that hyperparameter tuning I have discussed in today's class, right? I haven't discussed yet, actually. Can we penalize a slope if it is reduced to zero? Then that feature has no impact on the model and we can neglect the feature. Can we penalize the slope? You are trying to penalize a slope itself, right? By penalizing your error term. So actually you're trying to control what? You're trying to control your slope. M is what? M is nothing but your slope. Try to understand in this way. What would be the formula for beta in lasso or raise? Okay, I think you were sleeping in between. I have very clearly, what is a beta, guys? I have very clearly mentioned that beta is nothing but it's a M. I got an answer from many of you. Beta is nothing but beta is a slope, by the way. So there is no like this one equation for a beta. सर पीसीए कहाँ पढ़ा है? बहुत सारे बैच में पढ़ा है. Okay, so these are the things, little bit of mathematics heavy. So I think today is going to be a last class for a mathematics heavy concept of this topic, at least linear regression. Uh, Tomorrow onwards, we have to look into a back-to-back implementation and deployment. So we'll go ahead with the implementation and deployment. That's it. So are we okay? Zoom is not allowing you to copy. Okay. Yeah, PCA is a real fun. Yeah, it's a math heavy, so it's completely like a mathematics. But yeah, you all will be able to understand. Math heavy means doesn't mean it's a very complex one. It's like a math heavy means it's a simple one if we can understand in that way. So for sure, you all will be able to understand in that way. I think we are good for today, right? Every one of us. Yeah, we all are good. You all are able to understand all the topics. Yeah. Okay. Fine. So I think today 2 hour is fine, right? Because when we'll do our implementation, maybe we can go till 3 hour, 4 hour, 5 hour. All right. People need some time to digest all of these things. So yeah, you can take you can digest. Do we need a to make HLDL document for online doctor visit app? For everything, you have to do it. Simple. Whatever instruction we have given to you, you have to follow. Yeah. This book is helping me a lot. Completed 6 chapters from it. Yeah, so even whatever I'm teaching you, right, so I'm teaching you from that book itself. So maximum I would say a theoretical material I used to prepare from that book. So yes, it's one of the best ones. So I always like follow that book. Name of the book, please go and watch your previous recording and my YouTube channel. You will be able to get it orally book. Yeah, I have already like told you that book name many times, and it's the only books. I think many people will suggest you that one book unless and until they are not doing a marketing for some other books, right? They will not suggest you. If you will ask any one of us for honest advice, unless and until we are not doing a marketing for some other publication, we will suggest just one book, and it's the same. Orally, machine learning, psychiatric Keras TensorFlow. So hands-on machine learning is the only book anyone will suggest you. Yeah. Yeah. If people are doing a marketing, then they will suggest you another 10 books. This, that, blah, blah. Kind of book. Can you share a previous task code? Need some help? No. So I think you should work on that by yourself. The task was not that tough. So I don't think that you need assistance in terms of code part. I believe we all can do it. So you have to do it. Right or wrong, 10% correct is also fine, but by yourself. At last, told them, yeah, in every class I talk about this book name, but every class I get the same kind of question. I don't know how to solve the copy paste problem in a Zoom. Even I'm like trying to figure it out because previously this was not a problem, but I don't know what has happened with Zoom, and yeah, so I don't really know. I can able to copy. Yeah, see, someone is saying that they are able to copy. Some of you are not able to copy. So even I'm confused. And from my side, literally, I'm not blocking any one of you to like a copy. So from my side, there is no changes in terms of setting is done. And I think like just take. Yeah, it's a better idea. Take a screenshot. Simple. Take a screenshot. I think it's fine. I'm able to copy from mobile. Okay, that's great. New technique. Try to join classes at least through a desktop, not through mobile. Just click for 5 seconds. Okay, so try to click for 5 seconds is the advice. After Zoom update, copy is not working. Yeah, because from my side it's working. I have copied and then I have pasted it. Right. I have not typed all those things. Someone from your side has typed and then they have given to me. Right. So maybe I don't know. Like this is the issue which I am like receiving since last couple of weeks. This was not an issue at all. And yeah, for mobile user, I believe it's working, but for like after doing a latest update, so it's not working for some of us. But yeah, that's fine. The screenshot, try to use snipping tool for screenshot. Yeah, that's me. So yeah. Okay, Zoom browser is not having that issue. Yeah, but at least that is not like I'm trying to control, so it's fine. Okay, fine, guys. So with that, thank you so much. Thanks, Ketan, for your PDF version. At least as a mentor, I can't share that part. I think people can uh, do it from their side. With that, thank you so much. What is the meaning of plus plus theme? So if you will check your mail, so I have added a couple of more users in the same one, right, from our side. So that is the meaning of plus plus theme. So I don't know whether, okay, maybe you are just a fresher, you have not worked in industry. Plus plus theme means, so we are adding other ones so that they will reply. That is the meaning of plus plus. Looping. It's called as looping. We all do that. Yeah. So generally in our mail chain, so this happens. So we do plus plus. Okay, fine. So this is the meaning. Professional experience. Yeah, maybe he's in college, right? He's in college. So that's like a expected thing. Yeah, in office we used to loop. Okay, so fine, guys. Thank you so much. Be ready for tomorrow. But whatever topic I have discussed in today's class, it's a direct topic that you can receive in your interview, right? A direct topic, direct question they can ask you from all of these topics. And don't try to remember any of the definition or any of the uh, like uh, any of the definitions or equations that we have discussed, right? It's not required. First of all, try to understand a real sense, like, okay, so why we are using it, what kind of an impact it is like going to give on what section, on what kind of a data, then you will be able to digest it in a much better way. If you will end up like just like memorizing your definitions, so in that case, the next 6 months we are going to talk about many more things, and all of these things are going to be like heavy. It's like very difficult to retain. But if you're like able to understand these things in a real sense, then you don't have to like remember things. You will be able to correlate very easily. Automatically, you all will be able to correlate. And in an interview, so you can answer. Yeah. So with that, thank you so much, guys. And I have member of 7 team. Yeah, start working on that. When you will make a squad. Target was this week. Let's see. It will be done. So when I said that it will be done, so sooner or later, so it will be done from my side. PUBG squad. So yeah. Yeah. Thanks everyone. Thank you so much. See you again tomorrow. Try to digest today's things. I'm not giving any task for today, right? Try to just digest it. That's it. And when you're coming tomorrow for a classes, back to back, I'll start doing a practical for everything that we have discussed today, whether it's a VIF, whether it's a coefficient correlation matrices, whether it's a ridge lasso or elastic. So back to back, everything we will try to experiment, right? So don't ask me tomorrow that what is the definition of this. So why you're using realization or why you're using ridge lasso or L1, because what I will believe is that you are already aware about it. Yes, so that I'll just like keep on typing each and everything, and I'll finish the practical work. If time allows, then maybe I'll show you a deployment of model as well in tomorrow's class itself. Otherwise, next week. Very simple. Please upload a video today itself. Yeah, team will upload it as soon as it will be ready. So again, this is not a problem from our side. So if it is like a under our like capacity, so we would have uploaded immediately. But the problem is with the Zoom, so it takes time to convert this 2 hour 3 hour long video. So that's the reason. So we say that in 24 hours we will upload. That's the only reason. Can I start intensive out of 7? Yeah, anytime you can start. Like yeah. Okay, guys. With that, thank you so much. See you again tomorrow, same time, 3 p.m. IST.